Yeah, I would do this on notebook paper because these are all squished up. And again, like the multiple choice, each of these is going to give you like half a page. And I don't mean for like all of number one. When you get to the AP test, like 1A will be like, you'll have half a page to work it. And 1B will be half a page. So you got lots of space to work and draw and sketch graphs and figure things out. All right, so let's start on number one. And again, I think I want to get through 2 and assign 1, but we'll see what happens. By the way, don't panic. No one's noticed or said it yet. This says BC review, but BC just covers a few extra topics at the end that we don't get to. And a lot of the BC exam, the questions are identical. And so, obviously, you're not supposed to discuss, but after the test, you will realize that on the free response question, I think it's 4 of them are the same, maybe 3 of them are the same, but there's always 2, 3, or 4 that are the same questions on AB as BC. So, because it's not harder stuff, it's just more stuff. All right, so yeah, this probably appeared in the AB test as well. The graph of the continuous function of G, the derivative of the function of f, is shown. So G is the derivative of f. Probably want to make a note of that somewhere. G is the derivative of f. So this is the graph of G. It's also the graph of f prime. The function G is piecewise linear from -5 to 3. Okay, so it's lines. Got it. And then from 3 to 6, it's this parabola. If f of 1 is 3, find f of -5. By the way, in theory, we should have 15 minutes to work this problem. We'll see. So I have the graph of G, and I want to know something about f. Well, if G is equal to f prime, how could I get to know something about f? So if I've got f prime, how do I get back to f? Take the integral, take the antiderivative. So let's integrate G or f prime is the same thing. So let's integrate G because that will give me f. But what values do I want to use for the integral? What limits do I want to use? I do want to use -5 somewhere because that's what I want to find. What's that?
1 and -5.
And let's use 1 since we know f of 1. So the integral of G from -5 to 1 would be f of top 1 minus f of bottom 1. F of 1 is 3. F of -5 is what we're looking for. How am I going to get the integral from -5 to 1 of g of x? How am I going to evaluate that? From the graph. What about the graph? I want the integral of g of x. Remember, that sign means 2 things. It means take an antiderivative, but it also means area under the curve. So I want the area under the curve from -5 to 1. So I guess I'll just piecewise, I'm just going to go piece by piece and write the areas on here. So that would be, let's see, that would be -9, that area. This area would be half of 3, so negative 1.5. And that area would be 1. So I add them all up. I get negative 9 plus negative 1.5 plus 1. Equals 3 minus f of negative 5. Okay, we've got safe stop approaching. I've got to solve for f of negative 5. But exactly how much of this I want to do is kind of up to me. Let's see, negative 10.5 plus 1 would be negative 9.5. Just don't mess up the algebra. So f of negative 5, move that over, would be 3 plus 9.5. And I can leave that as my answer. I don't have the scoring guideline for this one, but my guess is you probably get 1 point for setting it up, and then 1 point for finding everything and solving it. This is my guess. That was A. Part B. Evaluate integral from 1 to 6 of g of x dx. Fold my paper over so I can see the... From 1 to 6. So, this symbol means two things. What does it mean? What are the two things it means? Antiderivative and area under the curve. So from 1 to 6, this is the kind of stuff that AP test throws at you. From 1 to 6, what are we thinking? How are we going to work this problem? What's that? Riemann only gives me an estimate.
You take the integral from 3 to 6 and then add to it.
I'm going to do them in the other order, but yes. So from 1 to 3, and 3 to, well, I don't want to do 3 to 4. I may as well do 3 to 6. Because 1 to 3, I can use area, and 3 to 6, I'll need to use the antiderivative. So that's kind of sneaky. They put both of them in one problem. So the area piece from 1 to 3 would be 4. The antiderivative piece, that's going to take a little bit more effort. The g of x is 2 times x minus 4 squared. Wait, you can't do math 9 because this is no calculator. So, we can antiderivative as it sits, or you could multiply it out to do an antiderivative. I think u substitution. Yes. And then du is just dx, so yeah, it's a pretty easy u substitution. 2 can just come out front. Do you want to switch the limits to u limits, or do you want to put all this and then switch it back to x? U limits. So 6 minus 4 would be 2, and 3 minus 4 would be negative 1. And now we've got everything in u, so I don't ever have to go backwards to x. Be careful, if you do this, you don't go back to x. We're all u now. So 2/3 u cubed from negative 1 to 2. So 2/3 2 cubed minus negative 1 cubed. And don't forget the 4. 4 plus 2/3 You know what? Let's not mess this up. Safe stop. What is that? I don't know. I don't care. If you want it greater, you figure it out. But I've done the calculus. So we can be good there. Plus there's a time element. It doesn't take too long to do 8 plus 1. But why bother? You don't have to. Leave it alone. But the trick on that one is realizing that part of this would be area and part of it would be antiderivative. Part C. Between -5 and 6, on what open intervals, meaning not too worried about the endpoints, just open intervals, if any, is the graph of f increasing and concave up? Give a reason for your answer. Well, this is where it's probably better to give a reason first and then go to the graph and look around and see what's going on. So if f is increasing, what does that mean? Or when is f increasing? Not from the graph, just in general. When what's positive? Yeah, so I want to know when f prime is positive. And by the way, f prime is the same as g. So I want to know when g is positive. What about f concave up? What does that mean in terms of f? Or f prime or f double prime? What's increasing? It means f prime is increasing. What's f prime though? G. So I want to know where g is positive and increasing. And so there's my answer already. So now I'm just going to go to the graph and look. I need g to be positive and increasing. So anything left over here, that's not positive. So 0 to 1 is positive and increasing. 1 to 3, it's flat. 3 to 4, it's decreasing. 4 to 6, I am positive and increasing. G is positive and increasing. It's also concave up, but I don't care about G being concave up. I only care about G positive and G increasing. Give a reason for your answer. Well, again, we did the reason first. That was part C. Part D. Find the x-coordinate for each point of inflection on the graph of f. Give a reason for your answer. So a POI happens when f double prime equals 0 and changes signs. Well, I don't have a graph of f double prime. I have a graph of f prime. So how do I get from f prime to f double prime? I want to give a reason in terms of what I know, right? F double prime is the slope of f prime. So I want to look for where the slope of f prime, or the slope of g, I don't have to say that because I already said they're the same thing, but if you want to make it kind of clear to yourself, I want the slope of g to be 0 and change its signs at that spot. This has some spots that are undefined, so I need to be careful. So the slope of f is 0 or undefined. That'll account for those cusp in there. So I need the slope of this line to be 0 or undefined and changing signs. So this is a little bit tricky because these flat places, it's undefined right there, but I don't think that's a point of inflection because it's not positive to negative, negative to positive. It's 0 to positive. It's positive to 0, 0 to positive, positive to 0, positive or 0 to negative. But at x equals 4, it's 0 and it changes signs. The slope is 0 and it changes signs. Now, kind of big picture. So that took, look at the timer. Look at that. 15 minutes. And that was me trying to go slow, trying to explain. Usually, not always, but usually time is not an issue on the AP test. Okay? I mean, there's plenty of issues. You're not going to know some. There's going to be hard problems on there. But it's not like, they give you enough time. They really do. Most of the time, it's not a timing issue. As long as you don't, if you get stuck on one, don't spend half an hour spinning your wheels doing nothing. Move on, try to come back to it. But generally speaking, timing isn't the problem. It's if you know the stuff or not. All right, we get out at 9:10. So that's 15 minutes. We could do one more and then I'll assign one. So let's look at number 1. I said the odds. If you start looking at these graphs, like they're kind of all the same. They give you the graph of f prime and then ask a whole bunch of questions about it that are kind of the same stuff. Like I said, they're all close to the same. Let's look at number 7. 7 had a wrinkle in it. I don't remember what it was. I remember I wanted to do it. Oh yeah, MVT and this 2x. So yeah, let's do number 7. The continuous function f is defined on the interval -4 to 3. The graph of f consists of 2 quarter circles. Okay, so those are quarter circles. That means I can find those areas using an area formula if I need to. And the line segment. Let G be, okay, this is new. I'm used to seeing G equals the integral from 0 to something, but they threw a 2x in there to mess us up a little bit. Find G of -3. Okay, well, G of -3 would be 2 times -3 plus the integral from 0 to -3 of f of t dt. Well, that was nice that they landed that on the end point of that quarter circle. So I can evaluate this using area formula. Pi r squared over 4, because it's a fourth of a circle. So 9 pi over 4. So -6. What do I need to be careful about here? It's from 0 to -3.
Oh, -9 pi.
So it's -9 pi over 4 because it's backwards. Or because you need to switch those and change the sign. This has 4 parts to it. I'm trying to think how they're going to divide up the 9 points. Since they ask for 3 separate things, they've almost have to make each one worth a point. So there's 1 point we earned. G prime of x. So the derivative of g of x. Well, derivative of 2x is 2. What's the derivative of the integral? F of t. Well, f of x. So there's another point we just got. And then g prime of -3. So 2 plus f of -3 would just be 2. Feel pretty good about that one. Again, your goal is to get a few points on all of the free response questions, and on some of them to like really max them out and be like, man, I got this one. I'm getting 8 or 9 points on this guy. I don't know if this is going to be one or not, but we got 3 points. Part B. Determine the x-coordinate of the point at which g has an absolute maximum on the interval. Justify your answer. What flashes in your brain when it says absolute maximum? Whether I heard it. A table. And what needs to be on the table? The endpoints. So I definitely need to check -4 and 3. And then if any critical points are on there, critical points of g. So that would be where g prime, oops, I don't want to say equal. I want to say where g prime is equal to 0. But they just ask us for g prime. It was 2 plus f prime. No, not 2 plus f prime, just 2 plus f. So that's kind of weird. So I want to know where 2 plus f of x equals 0. So I'd like to know where f of x equals -2. Well, I don't think it's at 2. Let's see, this point is 0, 3. So the slope of that line is -2 to get there. Okay, well this isn't too bad. So what value of x does the graph hit -2? Where is f of x equal to -2? (2.5). It's kind of annoying, but whatever. So we'll have to check 2.5. Did we already find any of these? Of course not. That would have been too easy. So now I got to find all of those. So g of -4, looking up here, would be -8 plus integral from 0 to -4 of f of t dt. So that's -8 plus, let's see, integral from 0 to -4. So going backwards, that would be -9 pi over 4. And then what am I going to do about that pi over 4? Is it negative or positive? It's negative. It's negative because we're going backwards. It's negative because we're below. So it ends up being a positive pi over 4. So that's a safe stop, but I'm going to have to evaluate which one's the biggest, so I may as well clean this up a little bit. -8 minus 2 pi. Yeah, -8 minus 2 pi. G of 2.5 is 2 times 2.5 plus the integral from 0 to 2.5. So 5 plus, they didn't do us any favors on the algebra on this thing with these halves, but whatever. 3 times 1.5 over 2 is the, man, that's annoying for a no calculator. So 3 times 1.5 is 4.5. So we'll call it 4.5 over 2. I mean, that's not the cleanest answer, but we don't care about clean answers. It's the right answer. How about the area underneath here? That would be, that width is 1, that height is 2. Oh, so that's just -1. So from 0 to 2.5, from 0 to 1.5, the area is 4.5 over 2. And then from 1.5 to 2.5, the area is -1. So what's a better way to say that? 4 plus 2.25. $6.25. Well, I don't have to be a math genius to know which one of those numbers is bigger, so I'm good so far. Now I need g of positive 3. So 2 times 3 plus the integral from 0 to 3. 6 plus, we already did 4.5 over 2. And now we need, oh, wait a minute. If I'm going 0 to 3 all the way, what's the total area? 0, right? Because whatever that area is equal to that area. There's some symmetry stuff going on here. So forget that. 0 to 3 is 0. So that answer is 6. Now let's make sure we answer the question correctly here. Determine the x-coordinate of the point at which g has an absolute maximum. So that would be x equals 2.5. X-coordinate. I would bet that's worth 2 points. All right, part C. Find all values on the interval for which the graph of g has a point of inflection. Point of inflection for g. We'll write what that means. G has a POI when g double prime equals 0 or undefined and changes signs. So there's my reason for my answer. I might have already gotten a point on that one. If it's a point for the values and a point for your reason, I may have just got one by writing that. Let's see. So we already have g prime equals 2 plus f of x, I think. Yep. So g double prime would be f prime, would be the slope of f. So I need to know when the slope of f changes, positive to negative. So when the slope of f changes, so positive, 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 negative. So at x equals 0. So there's another point. I bet we're up to 7 points on this one. Part D, find the average rate of change. Average rate of change, that's just good old algebra 1 slope. The average rate of change of f between -4 and 3. So I'm just looking at the graph, so I just need f of 3 minus f of -4 over 3 minus -4. So I don't think there's anything to do with g or derivatives. That's just algebra 1 work here. F of 3 is -3. F of -4. Yeah, I can't safe stop there. I need to fill in the function values, but I'm close to a safe stop. F of -4 is -1. And then, well, if we really want to be annoying with our safe stop, we can stop right there. That's the average rate of change. There is no point for which f prime is equal to the average rate of change. Explain why this statement does not contradict the mean value theorem. Well, the mean value theorem has to be continuous and differentiable. And f, is f continuous on the whole thing?
Yep.
Is f differentiable on the whole thing? On the whole interval?
Probably not at 0.
Not at 0. F is not differentiable at x equals 0. So my guess is there's a point for finding the average rate of change and a point for that one. So that last one was tricky. You have to know the conditions for MVT. Maybe you don't get that one, but hopefully you get the rest of those points. All right, so for homework, try number 3. So your assignment is one of those, number 3. More of the same stuff. Try number 3. Oh, and time-wise, that one took 15 minutes as well. So we're right on track for time.